and welcome to Getting APIs to Work. A little while ago I talked about the new IETF working group that is called Building Blocks for HTTP APIs. This working group is now having their first meeting at the IETF 109 meeting that is happening in November 2020. And I'm really glad that I can present 3 documents that maybe will be adopted by the working group. All of these are documents that I've worked on with co-authors. They're small building blocks for HTTP APIs. And just in case you're interested what's going on and what kind of documents maybe you can see in that working group, what to expect, maybe also what you might want to contribute, or just ask whether the working group would like to take up some work, I want to talk a little bit about those drafts and will briefly present their history, their motivation, where they're at, and hopefully some people will find those drafts interesting. For those of you who don't know me, my name is Erik Wilde. For the last couple of years I've been working for software companies that are producing some kind of API management software. So I talk to a lot of companies building APIs, looking for infrastructure for APIs and so forth. So most of my input comes from organizations that are trying to build APIs, often a large number of APIs, and that are trying to come up with more productive ways of doing that. And a lot of that means having guidelines or standards. So that really is my main input, is to have those discussions about possible ways of how you can build APIs with more standardized building blocks. Let's move forward. The first draft that I want to present is about API deprecation. This is a draft that was written in collaboration with Sanjay Dalal. The idea is that, very similar to the RFC about the HTTP header field sunset that allows APIs to announce that they are going to be shut down, it would be useful to have something that works very similarly, but that talks about API deprecation, meaning that the API is no longer recommended to be used even though it is still operational. That would allow implementers to understand that maybe they should start looking for alternatives, they should look at what is going to change, meaning that API consumption can become more stable. The model is very simple. The idea is that an API that is going to be deprecated or has been deprecated will use the deprecation HTTP header field. It's a very simple header field, just containing a timestamp, and that allows API users to understand the fact that the API will be or has been deprecated. Where this API header field is appearing, whether it appears on all resources or just on an API's home resource, is up to the API designer to decide. And that again is a pretty good similarity with the sunset header field that works in the same way. The draft also defines a deprecation link relation that allows an API to link to associated resources where additional information can be found. For example, developer documentation that talks about what deprecation means, whether there are alternatives available, anything that the API provider might find helpful so that people can better deal with the fact that an API will be deprecated. In terms of this draft's maturity, it has been around for 4 versions now. Development started in February 2019. It's fairly stable by now. There's a good number of implementations already. A couple of implementations really use the deprecation header field. Some other implementations use a different header field name because it's not yet a standard. But we do see that this is something that API designers would like to use as part of their API design patterns. So it's probably something that will see quite a bit of uptake when it's available as an actual standard. Let's move on to the next one. The next one is a little bit more complex, I would say. It's about link sets. So this draft has been developed in collaboration with Herbert van der Sample. And the idea is that we start with the assumption that RFC 8288, that standardized web linking, that we would like to use those links, but to use them in a standalone resource. Motivating scenarios for this are, on the one hand, you might have resources that have a lot of links associated with them, so you don't want to put all these links into a header field. And another motivation is that you might want to have a scenario where you get a resource from one URI and you get the links about that resource actually from a different URI, from a different provider even, allowing you to have something that is often called third-party links. The resource and the links regarding the resource are actually coming from different parties. What the draft does is it defines this linking model based on RFC 8288, but it also defines a JSON syntax. So we define two media types. One is the original header field syntax, straight from the RFC, and the other one is a JSON syntax that we carefully designed. That was the biggest redesign we had somewhere halfway along the way to actually work well with JSON LD, because that was something that people felt was important if we do design JSON, to design it so that it works well with JSON LD. There's some specific rules around how to handle anchors, because now that a link set is not necessarily just in an HTTP header, it can become more important to make sure that you know what those links actually apply to, so the anchors of those links. But these are some details we don't have to go into. Here's a very simple example of a link set. As you can see, it's a simple JSON structure. In that case, we have two links. Both have explicit anchors. They have a link relation and they have a target. So pretty straightforward, I would say. The history of this draft, this one goes back pretty far. We started developing it in December 2016. There have been 11 drafts in the meantime. Like I said, one of the big things that we changed along the way was the JSON syntax to make it more JSON LD friendly. And we also have worked a lot on making sure that we really have a good mapping between the native syntax, so to speak, and the JSON syntax. This draft also already has some implementations. So we have implementations in library systems by my co-author Herbert van der Sample. He's from the library communities. And we have some implementations there. We also have GS1 looking into possibly adopting this. They are heavily in favor of this becoming a standard because they think for what GS1 does, so GS1 is the organization standardizing all the barcodes that you find on products. For this kind of model, it actually is very useful to use links that you can serve from a separate location as standalone resources. So GS1 is also very interested in this draft becoming an RFC. Now let's move on to the last one. The last one is content warnings. And content warnings is a draft that was developed in collaboration with André Zedig. The idea there is, or the motivation is, that there is an RFC for error messages in HTTP. It's called Problem Details for HTTP APIs. It defines a specific JSON structure that an API can return in case of an error. That is an RFC that has seen a lot of uptake because it's useful in many cases to be able to report error messages, and it's useful when you don't have to reinvent a syntax every single time that you're designing an API, so it's a very useful building block. And the warning draft should do something similar, but a little different in the sense that the idea is that if a request has been processed successfully, but there were some warnings along the way, which you might ignore, but you also might find interesting to look at, then you can signal that with a specific HTTP header field that is called content warning. And that header field then allows you to say that in the response, there's an embedded warning. So the model behind that is that content warnings make the statement that everything was basically done successfully, but there were some warnings along the way. And if you're interested in the warnings, then there can be different ways how these can be signaled. One way of how we do this is we can say it's an embedded warning. The draft proposes for this to be a registry. The only value we define is the embedded warning value, but there can be other types of content warnings that you could envision. So this is why we use the registry in that place. What the draft also defines is a JSON structure that if you have a JSON API that you can use to embed that warning information in a resource so that clients processing the response can easily see that there is a warning because there's the header field, and they can easily use the warning because the warning uses a JSON structure that is reused across APIs and is not reinvented every single time. Here is a simple example of how this warning structure can look like. What you see here is a request, a post request that has been sent, and then the response is 200 OK. So generally speaking, everything went fine, but as you can see, there's a certain warning element in the JSON structure, and this warning object that you see in this JSON structure, the structure of this is also specified in the draft. It's not necessary to use this kind of JSON, but it may be a useful building block for APIs if you are interested in using this warning model. This draft has seen 3 versions so far. It was first published in November 2019. We do see some implementations, but it hasn't seen a lot of uptake so far, I would say. I do believe that it is a model that probably could be used in a good chunk of APIs, but it's something probably where if we discuss it in a little bit wider community, where I could imagine that maybe some changes are made to the way how this mechanism works. And with this, I am done. I would like to give you a final overview of all the drafts. On this slide, you can see all the drafts and all the relevant links together. All the slides are available online, so if you want to navigate those things easily, just jump to the slides and you can explore all the drafts and all the associated resources from the slides. And with that, I would like to thank you for your attention. Again, the slides are available online at the URI shown here, and I hope that we will have a good discussion of those drafts and if and how they will be adopted for the HTTP API building blocks working group. This concludes my presentation of those 3 drafts. If you find them interesting, please comment. If you have other ideas, just let us know. Ideally, start participating in the working group. Like all IETF working groups, it's very easy to participate. You don't have to formally join or do anything. You can just jump in and start participating in the discussion on the working group mailing list. And if you have any ideas or contributions, just join us, and I'm sure it's going to be interesting. And in the long run, I think it will be very beneficial for the API community. Bye.